Hello and welcome to Aviation 101 with Laura. We are continuing our practice aircraft dispatcher oral exam. It's been a long time coming, a lot of requests for this, and this is going to be focused on task C. I'm going to have to break this up into multiple parts, but we're going to start task C with weather observations, analysis, forecasts. Again, I'm going to release two versions. One will have my answers. One is just me asking questions for you to practice. Please go back and check out the playlist I've been building so you can see other videos in this series and you can practice for your aircraft dispatcher exam review. Honestly, this is also a really great review for other types of check rides for pilots as well. So, task C. Like I said, this is going to have to be a multi-part thing because there is so many aviation weather information that you have to be able to read as an aircraft dispatcher. No way I can possibly unpack all of it, but it says obtaining, reading, and analyzing the applicable items. Okay, it does say that if you aren't going to use current weather reports, the examiner is supposed to simulate the weather information for you. And then there's a parentheses are the examples as appropriate. Now, I'm going to say right now, some of these items are not really a currently used thing anymore. I have had serious problems finding, for example, the constant pressure analysis chart. They seem to be mostly discontinued. Some airlines may have their own proprietary product. I can't find them on aviationweather.gov, but that's okay. We are just going to go with as many things as I can come up with. So let's start with, because basically they want you to obtain, read, and analyze items. Okay, so it's going to center around your simulated flight for your practical exam, like the one that you planned. But I'm going to start off with the very simple stuff. And basically I went to aviationweather.gov. I'll show you how to find these so you can practice. I went to products, METAR TAF data. I actually looked first at the big picture overview of the United States and zeroed in on some poor weather areas, which is right now my hometown of Wisconsin, home state of Wisconsin. I grew up in Oshkosh, Wisconsin, but here we have some METARs, so we can practice and I will be the examiner. And then I will answer the questions and we will go from there. So yeah, let's take it away. All right, so here is a series of METARs for Milwaukee. Please read for me. I'm going to actually load more. Please read for me this METAR that I have highlighted right there. Okay, no problem. So this is a METAR for Milwaukee on the 16th of the month at 17:52 Zulu. The wind was from 040 at 8 knots, visibility 1 mile, 1 statute mile. On runway 1 left, the visibility of the RVR was greater than 6,000 feet with smoke. Vertical visibility was 1,800 feet in that smoke layer. Temperature 26 Celsius, dew point 18 Celsius, altimeter was 3008. And then we have some remarks. The observing station can detect precipitation and the type. The tower visibility was reported as 1¼ statute mile. The sea level pressure was 1018.1 millibars. The current temperature at that METAR observation was 26.1 Celsius and dew point 17.8 degrees Celsius. And the highest temperature in the last 24-hour period was 26.7 degrees. The lowest temperature in the previous 24-hour period was 22.8 degrees. And this is the pressure tendency, which I'm going to actually pause and just say this is the pressure tendency. Honestly, I don't remember off the top of my head what is the pressure tendency thing. So that would be a great point to just stop and then see what they say. Now, if they say, oh, well, can you read the pressure tendency? Okay, I would say yes, but I'm going to have to look that up. And then I would make sure I have a source from the FAA, like the Aviation Weather Handbook, would be ideal to bring a printed copy so that you can look that up and you look that up. Now, if you want a way to study, I'm going to plug my own website on theaviationvault.com, my website, and then you go to Study Help, Study Guides from this little drop-down menu, and then select this US METAR decoding. It gets this handy-dandy PDF, so you can check this out. And here is the pressure tendency, so the 5 group, and that said it was 8. So that means it was steady, and then the last part of that METAR was 005. Okay, so it was steady, and it went up by 0.5 millibars. Also, I just realized that I made a slight error in the temperature because that was the highest temperature in the previous 6-hour period, not the previous 24-hour period. The 24-hour period max temperatures is a 4 group, and that was not actually included in that METAR. So even I made a mistake. I'm sorry, guys. You can yell at me in the comments. Okay, so there you go, reading a METAR. Go back to being the examiner. Okay, so this TAF for Milwaukee, can you read to me the applicable weather for an arrival at 2020 Zulu in Milwaukee? Sure, I can do that. Okay, so this TAF came out at 1720 on the 16th. It's valid starting on the 16th at 1800. And this first line takes us through the 17th at 100. So are we arriving on the 16th at 2020? Yes, okay. All right, so then the applicable line would be this top line of the TAF. The wind is forecasted to be 080 at 7 knots, visibility 1 mile in smoke. The ceiling is broken at 1,800, and then there's another layer overcast at 25,000. So apparently they're having some issues with smoke there. Okay, awesome. All right, so let's try another METAR reading, and we could go through and read this one. If they want me to read that one, I will go ahead. So this is for Madison, Wisconsin on the 16th at 1753. The wind was variable at 5 knots, visibility 1¼ miles in smoke. Few clouds at 5,500, and they are towering cumulus. Temperature 31 Celsius, dew point 17 Celsius, altimeter 3007. Remarks: there is an automated precipitation discrimination on the system. And my page reloaded. There we go. The surface visibility is 2 statute miles. The sea level pressure was 1017.6 millibars. Towering cumulus was observed to the south. Temperature 30.6 with tenths, and dew point 16.7. The highest temperature in the previous 6 hours was 30.6. The lowest temperature in the preceding 6 hours was 22.2. The pressure tendency is it was steady, and it rose by 0.9 millibars since the last 3-hour pressure trend. So what causes a SPECI to be issued? Okay, a SPECI is issued whenever there are some criteria documented by the FAA in the Aviation Weather Handbook that are outside the normal parameters of when a METAR is issued. The METARs are going to be issued every hour, but there are certain criteria such as drop in visibility, a beginning of a thunderstorm, a significant change at the ceiling, a tornado being observed, various weather phenomenon being observed that would prompt a SPECI to be issued, and it would be labeled as such. Here is an example of one right here in Green Bay, Wisconsin, and this one came out on the 16th at 2049, and I'm not 100% sure what prompted them to issue this other than the visibility went up, possibly the ceiling coming down, and the wind started, but it's only 4 knots. So I'm really not sure why they made that SPECI, but that's an example of how you would see it on a METAR series. So we talked about TAFs. Let's move on to some of the various graphical information. So the GFA, what is that? Okay, well, that is the graphical forecast product. So I can go to, let me go to the right thing. So on decision support imagery under tools, and I can go to decision support imagery. I can click GFA, and let's just choose 3, and we'll choose the central part of the United States because there's things happening in the surface. So here we go. This is my surface forecast. And what this data gives me is a big picture view of what is going on. We have precipitation symbols, weather symbols on here. We have got also a shading, and color indicates what type of precipitation and what level of precipitation is expected, as in like, is it chance of it or is it likely to be happening? So for example, we actually do have that smoke symbol up here in the Wisconsin area and the Chicago area. Fun fact, if you guys like the smoke symbol and that little FU code, which I think is funny, you can go on my website. Oh, that's not the right mug. You can go on my website and you can obtain a mug and put that on your desk if you like that smoke symbol. So, haha, tie in with that. But let me go back to my page here. So we have smoke, we have thunderstorm symbols. The color determines if they are numerous expected coverage or scattered or isolated. So in southern Illinois, it is expected to be numerous thunderstorms. We also have the 2 dots, that's a light rain symbol, and notice it is a lighter green, so that means it's a chance. And we also have wind symbols for the surface wind expectation. If it's a little red line, that means it's gusting. So yeah. Okay, so tell me about the wind in central Illinois. Okay, so in central Illinois, we have a wind barb that is coming out, like pointing to the southwest. And so we want to think of this like where it's coming from. So it's coming from the southwest. It has one little tick mark, and that means it is coming at 5 knots. I can't tell you exactly what direction. I can just estimate from this. So yeah. What is that shaded area of purple up there? Ah, okay, I'm glad you asked. So this purple shaded area, I can correspond to this. That is an air met for IFR conditions that is happening right there. An air met is for generally smaller aircraft. I mean, it matters to us with big aircraft as well, but an air met is just one of the things that we want to watch out for. And they issue them for IFR, among other reasons. Okay, all right, let's look at some other information regarding thunderstorms. And since we're looking at thunderstorms in this area, let's take a look at the Storm Prediction Center's convective outlook. Okay, so I'm going to pull up the convective outlook. How I get to it is from this page, actually. I can do Tools, the Traffic Flow Management Portal, and then we can do the SPC Day 1 Outlook. Okay, so here's my Day 1 convective outlook. All right, so what's the significance of the light green area? Well, this light green area is a general risk of thunderstorms. Not expected to be severe thunderstorms, but just a general risk of thunderstorms. What about this area in Montana that is yellow? What is that talking about? Okay, so that is, if you look at the legend, always make sure you just look at the legend. That is yellow, meaning it's a slight risk of severe thunderstorms in that area. Okay, and what about the darker green? Okay, again, looking at that, that is a marginal risk of severe thunderstorms in that area. Let's take a look at the TCF. This is what is the TCF? Okay, the TCF is the Traffic Flow Management Convective Forecast. It is created for generally ATC purposes. Dispatchers can look at it, but it's basically trying to help air traffic controllers with determining how convective activity may affect operations in around the country and how much coverage is expected. So we can take a look, like for example, it looks like central Missouri, it's expected to have some heights of up to 39,000 feet. And looking at that coverage, it looks like it is sparse coverage expected. It's a little hard to tell because it's very small. Let's look at some other support graphics. So again, I will go to Tools and Decision Support Imagery. And let's look at a view of SIGMETs. So what is a SIGMET? Okay, a SIGMET is a significant meteorological weather alert, basically. These are showing us, for example, all these SIGMETs on here today are convective SIGMETs. And I can tell that because it says conv in front of it, meaning they all have to do with thunderstorm activity. They are issued for embedded thunderstorms, for large areas of thunderstorms, for thunderstorms that are in lines with a strong amount of coverage. And they are also issued for areas of severe thunderstorms. Okay, awesome. And what are these numbers on here? Those are where the tops are expected to be up to. So here we have convective activity up to 45,000 feet, okay? That's what these are. Now, an easier way to look at this is probably, I'm gonna go to Aviation Weather Center. Let's actually look at this one that we were looking for in the central United States. Okay, so here is a convective SIGMET. We've got a numbering system. We have the times. It goes up to 45,000 feet. It's moving from the south. That's 180 at 5 knots. And we can see that it was issued at the 16th of the month at 2055. The convective SIGMET is numbered 99C. It's an arbitrary numbering system. It's valid until 2255. And it's for Tennessee, Kentucky, Indiana, Illinois, Missouri, Arkansas, and Kansas. It is an area of thunderstorms from 50, and you could plot all this out, but they've drawn it for you. Yay, so I'm not gonna plot it all out, but this is referencing VORs. It is moving from, an area of thunderstorms moving from 180 at 5 knots, tops above flight level 450. And then they're going to give me, if I keep going, an outlook of what else is expected in another mapping out area. WST is just shorthand for more convective SIGMETs. So WST issuances are possible, and so they want you to refer to the most recent SIGMETs from the Storm Prediction Center that issues all of these for all the details. And then there's another area. If we look at radar, what are we seeing here? What is radar really? Okay, well, radar is essentially a microwave pulse getting sent out by the radar dish. There's a number of them around the United States, operated by the National Weather Service. It sends out a pulse and then it scans the sky at regular intervals. It takes all the information back and it creates these views of thunderstorms so that we can see what kind of precipitation level is coming out of the thunderstorms. Now, it's important to realize that radar shows us precipitation. It does not show turbulence. Turbulence can be extremely dangerous for aircraft, and so I would want to route around thunderstorms, but also pay attention to the area around the thunderstorms and not just be avoiding the precipitation areas, because there is danger in areas where there's no precipitation around thunderstorms. Okay, well, while we have this on, let's turn on the satellite view. So what is this view and what is this good for? A satellite observation. Okay, a satellite observation is helpful for us to see weather coming from a long ways away. For example, I don't have any hurricanes currently in the Gulf, but we can take a look at where there is cloud coverage. By using a satellite view, you can actually almost see that some of these tops are a bit ragged, may be able to infer that that's some convective activity. Again, we would like to include the radar information as well, and that helps us fill in that picture. But we can also use the satellite view, to see weather coming from a long ways away. And that is just really helpful for me as an aircraft dispatcher. Also helpful for if I am dispatching on, say, for example, trans-Pacific flights, there's no radar available, or transatlantic, there's no radar in the middle of the ocean. And so I can use satellite observations to get some information about the weather that's happening over those types of areas. So that's why that's helpful to me as well. Awesome. Well, that's probably enough for today because, enough for this video anyway. I'm going to continue with this series. So keep staying tuned for more videos because I did not get through all these areas like I thought. We basically got into 1 and 2, but we will come back to looking at like PIREPs. We did look at satellite weather imagery, but we will come back to looking at PIREPs, the surface analysis, and other information from aviationweather.gov, the high-level significant weather prog charts. Got a lot left in this Task C, weather observations, analysis, and forecasts. So thanks for watching Aviation 101 with Laura, and have a great day.